The moon is just one of those dependable constants in life, at least for life here on Earth. But it wasn't actually always there, and over the years scientists have come up with a lot of different ways to try to explain how it got there in the first place. We've discussed the different theories of where the moon came from, but the most popular one is that around 4 billion years ago, a giant planetoid or impactor around the size of Mars hit the Earth while the Earth was forming. The theory goes that chunks of both the impactor and the Earth got knocked off and eventually joined together to become the moon. Makes sense. That's the one we've all heard. Well, this week that hypothesis hit a small but very tough snag. A snag made of tungsten. According to the theory, the impactor should have had different concentrations of elements than Earth did at the time, and those differences should show up on the moon since it was mostly made of rock from the impactor. So scientists have been trying to get to the bottom of the moon's formation by studying the composition of moon rocks and Earth rocks and looking for differences. But according to new research published this week, when it comes to tungsten, there is no difference. Both Earth and the moon ended up with roughly the same concentration of the metal after the big split. Two research groups, one based in Germany and the other in the US, measured the tungsten levels in samples of lunar rock brought back by the Apollo astronauts. After accounting for changes in tungsten concentration caused by all the meteorite impacts that happened long after the moon formed, the researchers found that Earth and the moon had the same concentration of tungsten when the moon first took shape. For fans of the impact hypothesis, this is confusing. Other studies have found that the same holds true for elements like titanium, silicon, and oxygen. Turns out the moon formed with pretty much the same concentration of all those elements as well. So some scientists have come up with ways to explain how Earth and the moon ended up with such similar concentrations of elements. It's possible that the impactor was made of the same stuff as early Earth, or it could be that when it hit, the moon was mostly formed from pieces of Earth's mantle that broke off. Either way, it turns out that even though the moon is the closest thing to us in the whole universe, we still have a lot to learn about it. Now, your average amateur astronomer can't go and measure the tungsten in moon rocks, but they can discover new supernova, which is exactly what a recent collaboration of more than 40,000 volunteer astronomers did. We've discussed how useful computer programs can be for analyzing huge sets of images from space, but sometimes there's no substitute for good old-fashioned human eyeballs. Using ZOONIVERSE, a platform specifically designed for citizen science projects, a group of astronomers from all over the world launched a project called Snapshot Supernova. Its aim was to enlist the help of ordinary people to sift through the huge volumes of data being collected by Australia's SkyMapper telescope to help identify new supernova in the southern sky. Volunteers were shown 2 images of the same patch of sky taken at different times by SkyMapper, plus an image that showed only the differences between the two. People were then asked to describe the differences, answering specific questions about their characteristics, like whether a spot that showed up was circular or if it was within a big bright area. If the volunteers' responses for a set of images matched the description of a certain kind of celestial object, and enough people agreed, then it was flagged as a new find. The more significant ones, like supernova, were then checked by researchers. The project ran for only 5 days in March, and volunteers finished looking through all of the available data, classifying nearly 2 million objects in that time, including variable stars, asteroids, and at least 5 new supernova. The results are still being analyzed, but according to a tweet from one of the astronomers working with SkyMapper, more images will be released soon, and they will need sifting too. If you want to volunteer for the next round, you can check out the link in the description below. Thanks to everybody who helped out with the SkyMapper project, and thank you for joining me for SciShow Space News, especially to our patrons on Patreon. If you want to help us keep exploring the universe, you can go to patreon.com/scishow to learn all the cool things you can get and to help us keep making the show.